Hello, today I'm going to be showing you how to do a load takedown for slab design. This will apply to all slabs. Then I will go on to tell you of other load takedowns. Let's start. The first thing we are going to look at is how to do a load takedown on. We are going to do load takedown on live loads. Okay, with live loads, according to BS 6399 of 1996, you will find out that in residential domestic houses, uniform distributed load will be 1.5 kilonewtons per square meter. Then for concentrated loads, you use 1.4 kilonewtons. That is the standard. So let's just leave it like that. You will find out that when we are doing a slab design, the load that we deal with is in kilonewtons per square meter. It's actually pressure. It's kilonewtons per square meter. Okay. Then after that, we are going to look at dead loads. Under this dead load section, we are going to look at the slab itself. Some softwares that we use, they do it automatically. Some account for the weight of the slab automatically, so you don't have to calculate it. But when you are doing a manual calculation, you have to take it into account. Okay. When we are given concrete, it comes as density. Actually, this is density of concrete. It's 24 kilonewtons per cubic meter. If we multiply it by the thickness of that slab, we will end up, this unit of measurement will cancel one of these units of measurements. So you end up with, in this case, for a 200 millimeter thick slab, you have 4.8 kilonewtons per square meter, which is in the same unit as this live load. Okay. Then when we have on a panel, we might have partitioning walls. Those walls that are, if you're in Zimbabwe, those walls are made of one half lift brick wall. Okay, so you have to add up all the lengths of the walls that are carried by a single panel. For example, let's say all those, they add up to 12 meters. Okay, if you multiply 12 meters by this unit, which is the thickness of the wall, which is in meters, and then you multiply it by the height of the wall, these are 3 units. They will cancel out with this one. Then you end up here with a load with just a force, like you end up with 500 kilonewtons. Then for you to be able to use it for our calculations, it has to end up as pressure. In other words, is kilonewtons per square meter. Okay, so other dead loads that we might have, for example, these point loads, which we have here. Okay, these point loads are things that we have that are immovable. For example, a wash hand basin, a water closet, and those kind of things, a chandelier. They will actually exert a load onto a slab. So that slab has to be taken into consideration. We have other loads like screed, like tiling. All those things have to be taken into consideration. Using BS 6399, you can find out this is part 1. We've got part 2 and part 3. It only deals with loading. Okay, so you research from that code, those three parts. You find out any kind of load, the load for tiles, the load for screed, the load for timber fixtures, and all that stuff. Okay, once you have those loads, then you add them here. For this example, let's say they add up to 25 kilonewtons. You add them for that particular panel. Then you divide by the length and which is LX and LY of that slab. Then you end up with this dead load. Okay, This is the dead load that we are going to use for designing of our slab. I'm going to be leaving a link so that you can download this MathsCAD page so that you use it for your own calculations. All that you'll be left to do is to just change the few values. For example, if you've got a 175 thick slab, you then change this to 175. Then it will adjust the loading, as you can see. Okay, thank you for your time. Please like, share, and subscribe. Thank you.